Good day everyone. Today we will be talking about building electrical system. So, let's go!
Electricity is all around us, powering technology like our cell phones, computers, lights, soldering irons, and air conditions. But what is electricity? So, electricity, it is a property of matter that results from the presence or movement of electric charge. According to modern theory, matter is electrical in nature. Next, structure of matter. Matter. It is anything that occupies space and has mass. Atom. It is the smallest particle of an element that is capable of independent existence. Molecule. It is the smallest particle of matter, an element or a compound that is capable of free existence. Next, basic data about the atom. Proton. Proton is a positively charged particle found in the nucleus of the atom. This is a tiny, dense region at the center of the atom. Electron. Electron is the particle that orbit the nucleus of an atom. They are generally negative in charge and are much smaller than the nucleus of the atom. Neutron. It is a particle with neutral charge. Unlike protons and electrons, which are electrically charged, neutrons have no charge. They are electrically neutral. Atomic number. It represents the number of protons or electrons of an atom. Atomic mass. It represents the sum of protons and electrons of an atom. Ion. It is an atom or a group of atoms that has a net positive or negative charge resulting from an equal number of positively charged protons and negatively charged electrons. Shell. It is an energy level or region about the nucleus of an atom in which electrons move. The atom has 5 shells, namely the K shell, the L shell, the M shell, the N shell, and the O shell. Last, valence electrons. Is the electrons found in the outermost shell or orbit of an atom. Here's the table of the basic data about the atom. Let's move on to electrical classification of materials. First, electrical conductors. These are materials that allow the essentially free passage of current when connected to a battery or other source of electrical energy. Electrical insulators. These are materials that possess low conductivity or offer a relatively high resistance to the flow of electric current. They are also called as dielectrics. Electric semiconductors. These are materials that have conductivity about midway between good conductors and good insulators. Electric current. It is the motion or transfer of charges from one region of a conductor to another. Its units, the ampere, named after André-Marie Ampere. Next, source of electric current. The following are the methods by which electric current can be produced. First, static electricity from friction. Second, thermoelectricity is electricity from heat. Third, piezoelectricity is electricity from pressure. Fourth, electrochemistry is electricity from a chemical action. Fifth, photoelectricity is electricity from light. And last one, magnetoelectricity is electricity from magnetism. Next, fundamental units of electricity. First, electric voltage. It is the driving force behind current flow. The unit of voltage is the volt. Voltage level governs the amount of current flow. An increase in voltage causes more current flow and vice versa. electric current. It is the motion or transfer of charges from one region of a conductor to another. Its unit is the ampere. Electric potential difference. It is the difference in the potentials of two charged bodies. Its units is the volt. And last, electric resistance. It is the property of a material that limits the amount of flow of current and converts electric energy to heat energy. Its unit is the ohm. Let's proceed to the Ohm's law. Ohm's law states the relationship between electric current and potential difference. According to Ohm's law, at steady state condition, the voltage across a resistor is directly proportional to the current flowing through it, with the temperature remaining constant. George Simon Ohm, a German physicist, was the first to verify Ohm's law experimentally. And here are the formulas for Ohm's law, where V is equal to applied voltage in volts, I is equal to the current drawn in amperes, R is equal to the resistance in ohms. Conditions for Ohm's law. First, Ohm's law can be applied either to the entire circuit or a part of a circuit. Second, when Ohm's law is applied to a part circuit, part resistance and the potential difference across that are part resistance should be used. Third, Ohm's law can be applied to the both DC and AC circuits. Limitations of Ohm's law. First, for metals which get heated up due to the flow of current through them. Second, for electrolytes where enormous gases are produced on either electrode. For vacuum radio valves. For arc lamps. For semiconductors. For gas-filled tubes in which the ions are generated because of current flow. So let's move on to electrical power. Electrical power is defined as the rate at which electrical energy is expanded or used up. It is the rate electric energy is converted into another form, such as light, heat, or mechanical energy, or converted from another form into electrical energy. Its unit is the watt. So here are the formulas for the electrical power, where P is equal to electrical power in watt, V is equal to the voltage in volt, I is equal to the current in amperes, R is equal to the resistance in ohm. And note, 1 horsepower or HP is equal to 746 watt. Next, energy. Energy is the capacity to do work. It is measured in joules. Electrical energy consumptions. It is the rate at which power is consumed over a specific period of time. So here's the formula for electrical energy consumed, where P is equal to electrical power in watt, T is equal to time, W is equal to electric energy consumed. Electric circuit. Electric circuit is a collection of electrical elements interconnected in some specific way through which electric current flows or it is intended to flow. Closed, open, and short circuits. Closed circuit. It is an uninterrupted path that allows a continuous flow of current through an electrical circuit. In a building, the circuit is closed when a switch is turned on. Open circuit. If the path of current flow is interrupted, such as if the switch in a circuit is open, an open circuit result. Short circuit. If an inadvertent shortcut develops in a circuit that permits current flow through an unintentional path, a short circuit is created. A short circuit occurs when current leaks out of the intended conductor, paths such as out of a wire with damaged insulation. Next is the types of circuit connections. First is series circuit. Second is parallel circuit. Third, combinational circuit. There's two types under the combinational circuit. First is series parallel circuit. It is a combinational circuit. When simplified, will result into a series circuit. Second, parallel series circuit. It is a combinational circuit. When simplified, will result into a parallel circuit. Last, series circuits. Series circuit. The circuit elements are said to be connected in series when they all carry the same current. Next, properties of a series circuit. Number 1. The same current flows through all the resistance. 2. There will be voltage drop across each resistance. Number 3. The sum of the voltage drops is equal to the applied voltage. Next is equivalent resistance of a series circuit. And here's the formula for the equivalent resistance of a series circuit, where R sub T is equal to total resistance. That's all for this video. Thank you for listening. Bye bye.